This is question 2 of the Unit 2 June 2015 GCSE Physics paper. On screen now is the mark scheme for the question, so please mark your work. Part 2C is on the next slide, so you may wish to pause the recording now so you can mark 2A and 2B, and on the next slide we'll move on to marking 2C. This is part 2C. Notice that this is a 6-mark question, so it's slightly more difficult in terms of the marking. You may wish to ask your teacher to help you with the marking of this question. Just looking at a few things that you need to do. I always start at the top, so you can see at 5 to 6 what are the sorts of things you need to include. You need to name the particles and give the polarity of the charge, so that's basically saying whether they're positives or negatives. You need to give the relative mass for at least 2, or the relative charge is given for at least 2 particles. Okay, that's what you're looking at for there. If you haven't given the relative mass for at least 2, or the relative charge for at least 2, you need to give the relative mass of the 3 particles and the relative mass of 1 particle to get the 3 to 4 mark. And if you've not really got stuff, you've just got a brief description with some names correctly, that's 1 or 2 marks. I could bring onto the screen now some of the points you should have included, so you could always add these to your work if need be. So here's a list of the points you should have included. According to exam board, I think that's a nice position there, so you could always add those on. Please feel free to move the recording backwards or forwards to help you mark this work, and as I've said before, if you need help from your teacher, don't hesitate to ask. If you got parts of that recording, if you got parts of this mark scheme incorrect, I suggest you listen to the rest of the recording to find out how to answer that question correctly in the future. So the first part of the question is talking about a plum pudding model of the atom. It says the scientists knew that the atom had negatively charged particles. They also knew that an atom had no overall charge. So the clue's there really, the idea that you've got no overall charge. So what did the scientists conclude about the charge on the pudding part of the atom? So if it contains negatively charged particles, but it's got no overall charge, the pudding part of the atom must have a positive charge. The mark here is for positive, you get 1 mark. For it to have no overall charge, that positive charge must equal the negative charge. Now you don't need the equals to the negative charge to get the mark there, it's just for the positive, but that's the idea, is that the positive cloud, which is the pudding part of the model, will have an equal charge to negatively charged particles. In part 2b, you get given lots of information, so it's kind of important to read through. So, 2 scientists named Rutherford and Marsden devised an experiment to investigate the plum pudding model of the atom. The experiment involved firing alpha particles at a thin sheet of gold. The scientists measured how many alpha particles were scattered. Using the plum pudding model, the scientists predicted that only a few particles would be scattered by more than 4 degrees. Over several months, more than 100,000 measurements were made. The results from this experiment caused the plum pudding model to be replaced by a new model of the atom, and your role now is to explain why. Now, what you should remember about the plum pudding model of the atom is that was a theory that the scientists had created, and this experiment was to test whether or not that was correct. And if that theory is correct, then what you would see in the test is that those predictions would have been realised, so that you wouldn't have seen more particles being scattered by more than 4 degrees. But in reality, as you probably know, is those particles were scattered by more than 4 degrees. So the idea that a large number than expected by 4 degrees or more, that will get you 1 mark. The idea that there was more than they expected, okay, being scattered through 4 degrees or more. And the next mark is that the predictions weren't realised, so the experiment didn't produce results that were expected, or the experiment contradicted what the prediction was. So you got in this part the idea that predictions weren't realised, or the plum pudding model couldn't explain the experimental outcome. And either one of those two things will get you the second mark. So here I'm just going to write measurements did not support prediction. And that will get you the second mark. Alternatively, you could have the idea that the plum pudding model could not explain the results of the experiment, and that would also be a mark for that point there as well. So for part 2BII, it says suggest one reason why other scientists thought this experiment provided valid evidence for a new model of the atom. So if we look back, what part of it made them think that it provided valid evidence? Well, we've got here that over several months, more than 100,000 measurements were made. Now those measurements, because you're taking so many, that will make it a valid experiment, because you've got lots and lots of data that's all saying and proving the same thing. So here what you want to be saying is that over 100,000 measurements were made. The idea that they've done lots of repeats would get you the mark as well, or the idea even that Rutherford and Marsden were respected scientists would also get you the mark there. So the last part of the question, question 2C, it says in this question you'll be assessed on using good English organisation information clearly and using specialist terms where appropriate. You should describe the model now used for the structure of the atom. In your answer you should give details of the individual particles that make up the atom and include the relative masses and relative charges of these particles. It actually not to include a diagram in your answer. Now, I personally think this was a very nice 6-mark question. I'm going to briefly go through the information you should include, so you're aware of it. I won't put this into good English because there's not necessarily room on the slide here, but you might want to put it into good English when you write it down and improve your work. So the 3 types of particles that you've got that make up the atom, you've got protons and neutrons, and then you've got electrons. I'm just going to very quickly do their charge and mass. Okay, so the charge of a proton is +1, that's a relative charge. Neutrons are 0, electrons are -1. In terms of the relative mass, protons and neutrons both have a relative mass of 1, whereas the electrons have a relative mass of about 1/2000, okay, or almost 0. The protons and neutrons you find they're both in the nucleus, which is a small central part of the atom, and it contains the majority of the atom's mass. The electrons are found in orbital shells, and that is mostly empty space in those orbital shells. I've now just dropped in the more detailed descriptions from the mark scheme. These are some things that I just made larger there, you can see. Some of the points you might want to include as well, just to get you a more detailed part to the answer. So you can see that I've got the idea that they make up the nucleus, electrons orbit in the nucleus, electrons are in shells, most of the atom is empty space, the nucleus occupies a very small fraction of the volume of the atom, the electron orbits are at a relatively large distance from the nucleus, most of the mass of the atom is contained in the nucleus, the nucleus as a whole is a positively charged part of the atom, total number of protons in the nucleus equals the total number of electrons that orbit the atom as well, which gives us the neutral charge of the atom. Now it would be worth just noting a few of those down if you weren't aware of them, just so you can include them in future questions, and it'll aid your revision and your understanding of the atom as well. And that brings us to the end of the recording, so thank you for watching.